Hello everyone and welcome back to Arctic Retro. In today's video I thought I'll take a look at some old equipment, electronic equipment. As you can see I have some old stuff around me here, and this is equipment for testing or using with electronics, so it's quite relevant. Before I begin, I just want to tell you that I don't know anything about these devices, and I don't have any experience with such old stuff, but I'm very excited to test them out. This is an old oscilloscope, and yeah, well, it isn't that old, but yeah, we'll check it out, see the specs on it. It's 20 megahertz, but as you can see, it's all analog. So if you followed my channel, you see that I use a more modern one that I connect to my computer regularly, but this is the old school, and it's quite huge. And that's one of the issues with this. I cannot really fit it on my bench. Well, I could, but then I need to take a big part of it that I'm using for other stuff. And here we have something completely different. This is a function generator or a signal generator amplifier, Sagita FGA 100K5. This video is sponsored by PCBWay. If you need to have produced your own PCBs, then just visit PCBWay and you can get an instant quote for your own PCBs produced for as low as $5 for 5 PCBs. They also do other stuff like advanced PCB. They do CNC machining and 3D printing, sheet metal fabrication, and prototype PCB assembly, among other things. Also visit their shared project site, where you can find a lot of already made PCB designs. So go ahead and visit PCBWay.com and check out their services. Never used one of those before. And this is a big power supply, and it can generate voltages up to 34 volts. Seems like it has some AC outputs here, and yeah, it runs on 220 volts. And it's also old school analog switches thing. Some meters here for volts and amps, so this is quite interesting. So where did I come across these things? Well, I got it from a friend in Sweden, Robert. So I just want to say thanks again, Robert, for this. What I'm gonna do with it, I don't know. It's just fun to have and make a little video about it in the first place, and then I don't know. I have no idea if the things are working or not, but that's a part of this video to check it out. So I thought I'll start with this one, this big and very heavy power supply. It's made by Elektro Hermas AB in Sollentuna, Sweden. And I have never heard about that company even, but I'm gonna do some Googling, see if we can find some information about it. Unfortunately, I didn't find any information about Elektro Hermas AB in Sweden, and the ChatGPT came out empty as well, so I guess it's not that well known. Yeah, and if we take a look at the label here, it says Elektro Hermas and EH8031, one phase, 220 volts, 50 Hz, and no secondary information. Given that there is no information about this company online, which I can find, I guess it's yeah, quite old and local. If you know anything about this brand, then I'd like to hear about it in the comments. Maybe even Robert knows. I guess this came from a school. I don't see any date outside on this cabinet, so it's hard to exactly say when it was made, but I think it's before the 80s or maybe in the 80s. Yeah, what do you think? Maybe I'll take a look inside and see if we can find some clues. But first I'm gonna test if it's working, and hopefully it's not gonna blow up or anything. It might have some old refas that may pop. Hope it doesn't. I'm gonna take my chances here and just power it on and see if we can measure the outputs. I'm a little bit anxious about this old stuff that has live mains power, must admit, but I have never actually experienced that anything has gone wrong. Once I had a computer where the reefer caps popped, and that was a terrible smoke and smell, but that's the only time I experienced something like that. I set it to 2, and that's 2 to 4 volts, and it's on DC. I guess this is for connecting it. I'm not sure. You see like a circuit drawn here. It's a diode down there, and this is the plus and the minus, and then it goes, I guess, like to some switch here to the 6.3 AC outputs, probably directly from the transformer or something. All right, let's turn it on then. It's alive. I don't hear anything. I don't see anything. There's no power switch on this, so yeah, I'm not really sure if it's on or not, or if you have to push this button here. I guess you have to. Oh, it lights up red. Let's see now if we push this button here. Nothing happened. Okay, let's measure the outputs here, see if there's anything. It's gone a couple of minutes now, so now I feel more confident. Didn't blow up. Yeah, it's a little bit unstable. 3.9 volts. Unstable might be because of dirty contacts. And if we turn it up a notch, 5, that's 6 to 9 volts. So it has a range of voltages, but it's 9.3. Yeah, now the voltage meter actually moved. Seems to be a little bit inaccurate. It seems to be showing only like 7. That's probably good enough. And if we check the AC on these, don't know what this switch actually does, but it's about 4.2. I think there's some dirty contacts there as well, but maybe you need to have it on the AC. So I'm switching to that now. And now we can measure, do we have 9 volts AC? 7, but it's 50 Hertz. And here we have 4.4. What if I push this button? No, it doesn't do anything. 4.5. No, it's 7. So this button doesn't have any effect. It's 50.00 Hertz. Yeah, so it seems to be working. So that's the activation button. But to measure the ampere, we need some load. I need to figure out how to make a load for this. So now it's on max 11, it's 28 to 34, and yeah, it's showing about 36. Yeah. So now it's quite accurate. Maybe I need to put a light bulb or something in just to see how much it can draw. Now I found this power resistor I can use. It's 3.9K, and if we know Ohm's law, then we have the current equals the voltage over the resistance. So let's say we have we set it to 12 volts and the resistance is 3900 ohms. Then we should get a current of only 3 milliamps, so that's not much. Yeah, this is 100 ohm, so that's 1 12 divided by 100. That's still just 3 milliamp. My previous calculation was off. It was in the microamps. That won't show us much either. Need a smaller resistance. Yeah, 22 ohms should give us, if we use 36 volts divided by 22, it should give us 1.6 amps. We'll try that. I'll just clean up the contacts a little bit. Yeah, just screw them right into these contacts. Yeah, I'm setting it to 4 to 7 volts. Let's see. Does it draw anything? No, that's a very little current. If we pull it up a little bit, yeah, we see the amp meter goes up. Oh, it starts smoking, so it gets hot. Yeah, very hot. Looks like a power transistor, but I'm not really sure about this, how much it can handle. Yeah, it says 5 watts, but that's not a lot of current. And if you, like we have now, we have, it's on 6, we have 9 volts. Just to check that. 9 volts, and the resistance, if you calculate the power, that's 0.4 amps. I mean, that's 400 milliamps. And if we calculate the power, it's 9 times 0.4, and that's 3.6 watts. The resistor is rated for 5 watts, so we can't go much higher than that, a little bit higher. Now, to test the higher power ranges here, I need something else, like a car light bulb or something, which I don't have. So yeah, let's see what happens if we turn this up a little bit. And you see, I already turned it up a little bit too much, and it changed the color. Let's see if we can burn this resistor. I had this lead on just to test something else, but yeah, take them off. Let's make it smoke. We get some amperes here, but no, it's max. Yeah, it's smoking. It's getting dark, it's burning. I tried to measure the temperature, but I think it's not very accurate in pointing. Yeah, there, 202. 206 degrees, and it's smelling bad in here now. Burnt electronics. Yeah, so this actually works just fine. That's amazing. So that might come in handy sometime later if I need some higher voltages than my bench power supply, the modern one, can provide, or some higher current. I'm just gonna quickly open it up if I can figure out how, and just to take a peek inside. That can be interesting, don't you think? I'm not gonna tear it apart or anything, just interesting to see how it's built. It has flathead screws, which was more common back in the day. By the way, this is and can be dangerous if you don't know what you're doing operating on these. One more there. Oops. So, yeah, it's loose. Just slide it back. Oh, yeah, that's interesting. Obviously, this big ass capacitor can still be dangerous to touch because it stores energy, and it's probably on the high voltage side. I can't really read the rating because it's on the other side. But it has a resistor across it, so I guess it's for discharging it. Nevertheless, I'm gonna measure it, see if there's any voltage on it. Now it's empty, so now it's safe. Now this is a very big transformer, one of the biggest I have ever seen here in my lab. So this is interesting. It's quite simple. It's just a big transformer. It probably has a various set of output voltages, which are then switched by these switches, something. This switch here probably routes it to something here. Maybe this is for adjustment. I have no idea. Yes, very big transformer, and it's quite heavy. I think it's at least 5 kilograms. What is this? Seems some sliding metal. Is this a capacitor? No, I don't know. But it seems to be something that can be adjusted, and then it's set to that. So maybe some variable resistance. Have no idea. If you know, then tell me in the comments. I don't see any rectification circuit, so maybe that's it. Something for rectification. I mean, it has 4 terminals. Down there is just some switches, nothing more, and the output terminals. So very simple. So this must have to do with rectification. It's some kind of diode, something. I've never seen that before. And I cannot find any date or production year or anything on this, so it would be interesting to see. Yeah, that was it for this power supply. While I have it open, I'm gonna try to clean up some of the switches here, if it's possible, with some contact cleaner. Just use a Q-tip as well. Yeah, now it's much better. Besides that, there's nothing more to clean. This switch I cannot reach inside. Only the contacts can be cleaned. I just slide the contact, this banana plug around a little bit, and loosen up old dirt and oxidation. Yeah, that was it. Old workhorse, still working fine. There isn't actually much that can break on these, I think. It's except for the transformer and that big capacitor. Let's check out the next thing then. Next up is this function generator from Arctic Retro, or no, from Sagitta. So I don't know anything about this either. I'm gonna Google it a little bit, see what it actually is, but it looks to be in good shape. Let's take a look at the back. Sagitta, and the product code, not much to see here. No date code. Well, no, it says date there. Yeah, 0706. So it's not that old. Only 20 years then, or 19. So what is a function generator, or also called signal generator? Well, it's hardware like this, or it could be software that actually generates different types of waveforms in different frequencies, and this is it. It seems to be able to generate sinus, sawtooth, and some square waves, and it outputs it through these BNC connectors, and yeah, it also has VCG in. I don't know what that is. Can also take some external input, audio amplifier. This is ground. So this can actually be used to test equipment that needs some kind of signal as input, like an audio amplifier, and then based on the input signal you give it, you can measure the output and see if it works as intended. But there's probably a lot of other use cases for it as well. So I'm going to test this with a modern oscilloscope now, see if we get anything out of it. Just going to turn it on first, see if it works. Yes, and it seems that you can change the frequency. So now it's 12 kilohertz. That's the max, and then you change the waveform you want. So let's put it in 20 Hertz or 19.54, and then I'll hook up the oscilloscope and see if I get anything from it. So you tune the frequency with this knob here. So it now is set to 10 to 100 Hertz. And if you want to have like 50 Hertz, you can tune it there, coarse and fine. Yeah. 50 Hertz. And the level is of course the voltage of the signal, and function out, we need to connect something there. So with this I got some cables also, so just hooking up here first, and then this one can go directly to the oscilloscope input. So now we should be able to see that waveform on the screen. Just need to start the Picoscope 7 software that works with this Picoscope. Yes, we have a signal. This is a waveform and looks to be 50 Hertz. Okay, so I added the frequency measurement and you see it down here. And yeah, let me change the frequency now. Yeah, we can see that it works. Set it to 100. And if I change the level, it's now at 2 volts. Let's say you want to simulate some TTL logic, but it doesn't rise from 0, so it's based on 0 volts. So to fix that you need to have an offset. I'm not sure if this can do that. But there's also a TTL CMOS out. I'm gonna change to that. So what do we get now? Yeah, there you have it. Now it's perfect 5 volt signal, TTL logic level, and you can change the frequency, but the level doesn't have any effect. So if we increase the frequency, now it's 1 kilohertz, and now it's 10 kilohertz, and now we need to change the time base here to be able to see it. Yeah, looks like a very clean signal. It has some spikes, but I guess that's not an issue. So changing the waveform doesn't affect the signal when you have a TTL. Let's go to the max. This is max 112 kilohertz. Nice, it works. So I move it back to the function out, set it to around 100 hertz. It's set to the square. Now let's try the sawtooth. Yeah, that looks perfect. And the sine looks perfect too. And we have this one, which is another type of square wave. This is the audio amplifier, so that you can actually listen to the signal if you want. If we hook up a speaker, we could probably hear the sinus wave and the sawtooth wave at frequencies below 30,000 or something, depending on your age. The VCG in, I don't know what that is. If you know, then please tell me in the comments. I googled VCG and yeah, seems like it stands for vector cardiogram, but it could be something else. But it's very handy with the TTL CMOS out, because then you can use this to simulate the clock signal if you're experimenting with some TTL logic circuits or something. Yes, so this works absolutely fine. So very nice to have. Now I'm gonna test the oscilloscope, and for that we actually need this as well. We could of course hook up a computer or something to test the oscilloscope, but since I have this out, I'm gonna use that. By the way, if I check Sagitta, it's actually a Swedish company and it's still in business, seems like. This is a more modern variant, digital function generator and amplifier, but yeah, it looks to be doing exactly the same as the one I have. I tried to find this exact model, but I couldn't actually find anything about it. Yeah, seems to be making lab equipment and stuff like that. Now, the oscilloscope. Yes, it's called GW Instech. GOS 620, and I think this too originally was used at the school, high school or something, and yeah, it seems like some branding it had before has been melted away. And this is not the oldest type of oscilloscopes, but it's not that modern either. It doesn't have a digital screen. It came with a couple of probes. One seems to be broken, it's missing the tip. If it doesn't have any trick to get it out, I don't think so. And the other one has some clip on it, so yeah. But I have a couple of other probes from other scopes I can use, obviously. Big, heavy, yeah. 5, 6, 7, 8 kilograms, I think. And the GW Instax seems to be in production still here. Yeah, this looks like more modern oscilloscopes, obviously. Let's see what the prices could be. It doesn't have any price information, just says sales contact. No, they only have digital oscilloscopes. Yeah, and I actually found this is oscilloscope that I have here, and it says discontinued, obviously. It's a 30-20 MHz bandwidth, dual channel, high sensitivity, TV synchronization, and yeah, channel 1 output. Specifications, you have a download there. Let's see if we can find the user manual here. Yes. Dual trace oscilloscope. For United Kingdom only. Yeah, always something special with United Kingdom. Yeah, and here it says Goodwill Instrument, and it's made in Taiwan, or yeah, made in Taiwan or China, I don't know. And it has all the technical specifications here, but looks to be kind of a simple user manual, not a lot of pages. Yeah, block diagram, and that was it. Yes, the website said that the company was founded in Taiwan in 76, I think, but this is not that old. Let's see if we can find any date. No, it doesn't say much. Made in China, takes 115 or 230 volts input, set axis output. I wonder what these large feet are for. Is it meant to be standing up if you want to? Maybe. Alright, let's power it on then, see if it works. Yeah, as I said, it has 2 channels, 1, 2, and it has some triggering functions here. Positioning, time division, positioning, X10, and if you're measuring AC or DC component, Alt, chop, and mode. Yeah, mode, channel 1, channel 2, dual or add. You can add the 2 channels together. This is the power switch, and this is focus and intensity of the screen. So I'm just going to hook up that signal generator again on channel 1. Yeah, let's turn on the thing and take a look. So I set the signal to a sine wave of 122 Hz. Turning on. Probably takes a while to warm up. And it's on channel 1, and set it to AC. There's nothing. So at 122 Hz, we need to set the time division correctly. But there isn't anything showing up. Have the intensity to max. No, it doesn't seem to work. Gonna check channel 2. Oh, there we have something. Yes. Now let's just tune this. Maybe it's some triggering. Channel 2. Doesn't seem to react to anything. Now set the frequency to 1.2 kilohertz. Horizontal position works, but it doesn't do anything. Well, now I got channel 1 working as well. I set it to TTL now. We got some sort of signal there. If I change the frequency, yeah, it actually changes. So it might be only me that doesn't understand completely how this works. Yeah, now we got something. So if we use triggering now and set it to TVV, then we actually have a stable signal here. Yes, nice. So now we can calculate the frequency by looking at the divisions on the screen, obviously. So it is working fine. I just needed to figure out how it actually works. And yeah, this is 10 kilohertz. Now I'm changing the frequency. And as you can see, it works just fine. Looks like a very nice, clear signal. The intensity and the focus works excellent. If I change the level, yeah, it goes up to 2 volts, I think, the level on the output. So this seems to be correct. Yeah, this works perfectly fine. Very nice. Change to sawtooth. Yes, perfectly fine. Tune it from the function generator. Very nice. That's so cool. That was channel 1. I'm gonna test channel 2 as well. And of course you can have them both active at the same time. No, it's on channel 1, changing to channel 2, but obviously this needs to be correctly tuned, adjusted. There it is. Change to sawtooth, sine, frequency, amplitude or level. Was this alt chop? Channel 2 inverse, you can inverse it. Alt chop is for channel 1. So if you don't have a trigger, then you just see the signal flying by. The trigger also needs to be set to the right source. You have a trigger in. I don't know how that works. Change to channel 1, trigger and set mode. So this alt chop button, I don't know what that is, unfortunately. Yes, so this works. Very nice. A good analog oscilloscope like this can be very good compared to a digital one. You see the signal is very stable and not like the digital where it renders on the screen. And so, very nice. But due to the size, I don't think I'll be using this much. It's nice to have. If I had a big room, big workshop or lab, I would probably set it up. But it is simply too large to set it up permanently up here in my attic. Yeah, of course I should have done this when I showed you before, but now you can see. Let's change the frequency to 108 kilohertz. Does it go that high? No, it doesn't, because it's only 20 megahertz. Oh, now I'm mixing. It's megahertz. Obviously it's megahertz here, but this signal generator can only go up to 100 kilohertz, so obviously it should be able to detect that quite easily. So 44 kilohertz, and yeah, maybe it's the triggering that's not able to trigger. Yeah, TV high, yeah, that seems to be more like it. So now it's at 108 kilohertz. So this trigger mode is either high frequency or lower. I don't know what normal is or auto, but seems like, yeah, there is a level on the triggering as well. Everything worked. Very nice. Alright then, that was it for this video. Very excited to have this old equipment, and it's still working 100%, and very fun to play around with. Not always the digital stuff is the most fun, but analog can work too. And again, I just want to say thanks to Robert for giving me this as a donation to my channel. If you have anything you want to donate to the channel and I want to have seen here, then just send me a message and we can fix that. So thanks again for watching, and a special thanks to my patrons, and don't forget to subscribe. See you next time. Bye bye.